Hello and welcome back. So let us try to understand more methods in Numpy. So to do matrix multiplication in Numpy, we have to use dot method. So I have created two matrices A and B and I am going to multiply them using dot method. So I can do A dot of B or B dot of A. And I can do A into B or B into A by doing A dot because A is a NumPy object and in that we have a dot method. Or we can do np dot of a comma b. So either way you can do it. So it's a matrix multiplication. I think we have already seen matrix multiplication in the previous video. So it is simple. And there are aggregate functions like sum, minimum, maximum, cumulative sum, and things like that. Let us try to understand those. So I have created a array with 12 values and a 3 by 4 matrix. So to create that, I have used arrange method. Arrange method will actually create a one-dimensional array with 12 values and then reshaped it to 3, 4, 3 rows and 4 columns. So it is like this. So 0 to 11. And if I use sum method, it is going to sum up all the values and give you the total. So 0, 1, 2, everything it totaled up and it gave me the 66. And if I say axis 0, it's going to sum up all the values in the 0 axis. What is 0 axis? All the rows. So it's going to sum up like that. So 0 plus 4 plus 8 and 1 plus 8 plus 9 and 2 plus 6 plus 10, 3 plus 7 plus 11. Like that it's going to. So when I say axis 0, it's going to sum up all the values in the 0th axis. That means all the row values it's going to sum up. If I say axis is equal to 1, it's going to sum up all the values in the columns. So it's like that it's going to sum up. See that? 0 plus 1 plus 2 plus 3 is 6. So it is actually keeping, so here it is giving you the value. So there is an attribute called keep dims is equal to true. If you say that, it is going to keep the dimensionality also. The original matrix is a two-dimensional matrix, and after applying sum on axis 0, if you want to keep the dimensionality as it is, it's going to give you a two-dimensional array here. So if I say how am I recognizing it as a two-dimensional array? This is one-dimensional array enclosed inside the rectangular brackets. So it created a two-dimensional array. By default, the value is false. So it's going to create a one-dimensional array. So that's going to be useful in doing broadcasting operations. So we have seen broadcasting in the previous video. Broadcasting is nothing but when you multiply a scalar, it gets multiplied with all the values. Or if two matrices dimensions are same, if you are trying to do subtraction or addition or division or multiplication, element wise it will happen. That is broadcasting. Okay. So so keep dims is another attribute which actually we'll use some places. And then cumulative sum. So we have said cumulative sum axis is equal to 1. So it's going to do a cumulative sum of the columns. So 0 plus the cumulative sum is going to be like this. Let me take a screenshot and explain. So the cumulative sum is going to be like this. So 0 and 0 plus 1, 0 plus 1 plus 2, 0 plus 1 plus 2 plus 3, and again the 4 plus 5, 4 plus 5 plus 6, 4 plus 5 plus 6 plus 7, and then 8 plus 9, 8 plus 9 plus 10, 8 plus 9 plus 10 plus 11. So I said axis is equal to 1, so it actually did that in the column way. If I say axis is equal to 0, it would have done it in a row way. So that is cumulative sum. So we can do all these kinds of operations very easily with NumPy. And then universal functions. So you can actually use the square root, sine, cos, all these trigonometric functions and all the absolute, all those functions are available. How to know which methods are available, which methods are not? You need to look into the API. So you can say, so you will get the reference, and there are all these details mentioned in there. Okay, so you can go through the documentation and do more experimentation. So here I have taken other method C, arrange 3, which will create an numpy array, one dimensional array with 0, 1, 2. And then I am using exp method. np.exp will create e power 0, e power 1 and e power 2. So e power 1 is 2.718, whatever the e value, right? Exponential value. And then square root. Square root of c. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is, I cannot calculate. Sine value. Now if I pass a numpy array to sine, it actually calculates the sine values of the, you can imagine them as degrees. Okay. You have add method. You can actually use c plus d also, but you can use add method also to add two matrices. And now the slicing. So you can do slicing and indexing as we have done it in strings and lists. The same rules hold true for the numpy arrays also. But when you use two-dimensional arrays, multi-dimensional arrays, it's going to be a bit complex. So let us see a one-dimensional array and two-dimensional array. So I have taken a numpy array, arrange 10, that is going to create from 0 to 9, and applied star star 3, that means cubes. So from 0 to 9, all cubes is a one-dimensional array I created here. And then if I, the index starts from 0, and if I say 2, it's going to give me 8. 0, 1, 2, the index. And slicing, from 2 to 4 I want, 2 to 5 I wanted. So it's going to be 0, 1, 2, from 8, 3, 4, 5. It's not going to give 125, it's going to give till 64 only. See that? It's a numpy array again. So the slice is also going to be a numpy array. You can use slicing with the colon, right? From beginning till 3, or from beginning till end, right? Or from 3, maybe fourth index till end, you can do that. This is all was done in strings and lists. The same way you can do slicing in the numpy arrays also. And there is stepping also. If you want to start at 2 and go till end doing step, so you can do that. Step 2. So it started at 2 and skipped to 27, 64 it gave, skipped to 125, gave 216, skipped, right? In the next there is nothing. So there is start, stop and skip is also present in numpy array slicing also. You can reverse the string, reverse the numpy array by using negative indexing. If you say -1, you can actually reverse the string. Negative indexing is also present in the numpy arrays. If you say -1, it's going to give you the last value 2729. Okay, so slicing two-dimensional array is going to be a bit complex, but it is simple. I will try to explain it in a simple way. Let us see. So here the indexing, right? I have created a array with 25 values from 0 to 24 and reshaped it as 5 by 5 matrix, a square matrix. See that the values are like that. Okay, this is an experimental thing, so I have created like that. If I say a two-dimensional array of 2, it's going to give you the second row or the index row, index 2 row, index with 2. So index with 2, the row with index 2 is third row. 0th index row is this one. First index row is this one. Second index row is this one. So it's going to give me that second indexed row. So by default, numpy arrays will take the row index as the index. Okay, if you want to access the second row and third column value, you need to give a comma in between. Okay, so let me execute this. So it gave me 13. See that? So second row is 0, 1, 2 and third column is 0, 1, 2, 3, right? So it gave me the intersection. So that value it gave me. Okay, so you can access multiple values also from the columns by passing the index like this. So 3 comma 1, if you say the first index value, right? The second row, the third row, and the first index is this one and the third index is this one. So it gave 11 and 13. Okay, so if you want to access the second row and third row and then third value and first value, right? It actually accessed the second row and the third value, and third row that means fourth row and the first value. So the first value is 16, fourth row and first value. So it is, if you give some value after comma, it's going to be columns. So if I say colon, all columns I wanted in the second row and the third row. That means all the values, all the column values, all the column values. It gave, all the column values from both of these second and third row. So you can do that. So if you want all rows, only second row and fourth column, you can do that also. Right? Only second column and fourth column it will actually give. You can actually access particular, specific indexes. Indexes should not be given in order. I am saying fourth row, 0th row, and second row. That means it will give me the last row, this row, and the first row. 0th index is first row, and the third row. In the order we have given, in which the order we have accessed it, it will give in that order. So that is actually, slicing and indexing on a two-dimensional array. So looping. You can actually loop through a two-dimensional array, and when you loop through, you will get one-dimensional arrays. The first row, second row, third row, like that. And you can loop through the values also. Each row is again a one-dimensional array. We can actually, do a looping on the array. So I am doing two for loops, nested for loops, and trying to print the values. We can actually loop through. Shape manipulation also we can do. So this reshape we have already seen. I have created arrange 20, that means 0 to 19 values, 19 numbers it will create. And reshape will actually convert it into 5 by 2 matrix. Or we can actually use the Ravel method. Ravel method will actually convert any dimensional array, whether it is 2-dimensional, 3-dimensional, 10-dimensional. If you use Ravel method, it will actually convert into a 1-dimensional array. This is very useful in deep learning, and we'll see that. So we can actually convert this, the 5 by 4 matrix into a 2 by 10 matrix also. So if you know only the number of rows you want to create, you can give -1 there, and it will create a 2-dimensional 2-row and 10-dimensional array. So we can do transpose of a matrix by saying dot capital T. It actually converted rows into columns. See this? This row got converted to column. This row got converted to column. This row got so it actually tilted the matrix like that. Okay, that's the transpose. We can actually do that. So these are all matrix manipulations. If you want to write code for this, it's going to be a tedious process. And Numpy is actually giving us these modules to actually do that easily. And reshape -1, 5. It actually known that 4 rows I wanted. Resize is a method which is very dangerous, because if you use reshape, it actually transforms and shows you, but the original matrix will not get modified. But if you use resize, the original matrix itself gets modified. If I say resize of 10, 2, it modifies the original matrix and shows you the output. Okay, so that's about the reshaping and resizing.